No matter what business you're in, digital transformation never stops. At Verizon, we keep companies ready for what's next. We weave security into their business, virtualize their operations, and build AI customer experiences. We also keep them ready for the next big opportunity, like 5G. Almost all of the Fortune 500 partner with us. When it comes to digital transformation, we're here and we're ready.
Hello and welcome to Does Artificial Intelligence Need a General Counsel? If you're joining us live, our speakers are in the Slido discussion answering your questions right now. For audio and video issues, please click the technical support button below. I'd now like to turn it over to Alan Brill and Paul Jackson for the presentation.
Hi, my name is Alan Brill, and I'm a Senior Managing Director in the Cyber Risk Practice at Kroll, which is a division of Duff & Phelps. For this presentation, I'm pleased to be joined by my friend and colleague, Paul Jackson, who leads our cyber risk practice in the Asia-Pacific region. Paul?
Thank you, Alan. In this presentation, we will be covering 5 areas. Firstly, where artificial intelligence is being used in business. Secondly, AI's popularity. Thirdly, what could and has gone wrong. Fourthly, how to course correct. And lastly, we'll wrap up with some key takeaways. So AI is being used in business, of course, and increasingly in all types of industry and for a myriad of applications. Logically, in areas such as customer experience, where we have non-human interactions with customers, R&D, where we're enhancing and speeding up research capabilities, finance, where we're helping to make faster and more accurate trading decisions, etc. But perhaps of most concern, as we will touch on in this presentation, is where AI predicts human behavior. Risks and legal concerns begin to present themselves. So by way of introduction, AI and its usage is only really getting bigger. And as McKinsey says, by 2030, the average simulation shows that some 70% of companies might have adopted at least one type of AI technology. And Markets.com predict that the AI market will grow to $190 billion industry by 2025, which is pretty staggering. And this is driven by the fact that 83% of businesses say that AI is a strategic priority for their businesses today. So as a starting point, why build AI? Well, obviously, if we think about traditional computer programming, it follows clearly defined rules. So in other words, it does what the human tells it to. Sorry, let's go back to that. It's the basic tenet. Corporate councils obviously understand this. It's based on rules, but they believe they're tech savvy, and they acknowledge their comfort level and confidence with technology, but they have limitations when artificial intelligence is making decisions for them and making decisions on behalf of their companies and organizations. A quote, everything we love about civilization is the product of intelligence. So amplifying our human intelligence with artificial intelligence has the potential of helping a civilization flourish like never before. But this has the proviso that we need to keep technology beneficial, and we need to understand the risks and concerns. Now, from my perspective as the APAC head of cyber risk for Kroll, I have particular focus on where AI is being used in cybersecurity. As a logical use case for this, detection and behavioral monitoring of cybersecurity threats is a logical use case. It's strongest here as AI can help to predict malicious behavior and how a human might try to adapt to defeat security controls that we have in place. It still needs to overcome the issues of falsely learning good behavior and identifying that good behavior as malicious, or flagging that good behavior as malicious. And we see in prototypes at the moment that this is indeed the case. Where AI still has a long way to go, though, in my line of work in particular, is in human behavior. So employee investigations, for example, defining when someone is guilty or showing deceit, identifying or predicting which humans might become a cause of risk to an organization or even to society in general. Let's look at insider threat, because in an age of crippling penalties for data loss incidents coupled with the high cost of reactive investigations after the fact, it's little wonder that organizations are looking for more effective programs to proactively detect insider threats. Many such programs simply seek to block capability to leak sensitive information, but to a percentage of organizations, they're now looking towards AI for something more robust. Tools that can predict employee risk before it actually occurs. Such tools can be very intrusive. You might think of them as Big Brother, Minority Report style tools, such as psycholinguistics, which is a prime example where profiling users or employees based on how they communicate and how they write is becoming an interesting field of predicting human behavior. On a broader scale, we see on a societal level increased use of AI to detect risks to public security. Perhaps most high profile is the Chinese social scoring policy. We've read a lot about this, and I'm sure you've seen this in the news. This combines factors such as physical public activities to activities online, such as use of social media, to actually define which individuals may be a risk to society. So what are the risks of getting this wrong? How might inaccuracies and biases affect critical decision-making within our organizations? I'm going to turn it over to Alan now to explain more about this.
Thank you. Well, Paul has talked about all of the benefits that we see in artificial intelligence, but the real question is what could go wrong? As Paul said, the systems that are being built with the best of intentions. But as we all know, sometimes good intentions lead to less than good results. I'll give you an example. This is a photograph of a weapons system used by the Navy. It's called the Phalanx or CIWS, Close-In Weapons System. It's a Gatling gun style cannon, which can fire over 1,000 rounds a minute of depleted uranium slugs. It is designed to knock out inbound missiles. So somebody shoots a missile at your ship, the artificial intelligence in this weapon system sees that on radar, fires the gun, and literally merges the outgoing rounds on the radar to the incoming missile and takes it out. And it's very effective. Unfortunately, a few years ago in one live fire exercise, once the system was set on automatic, it saw an incoming missile, which was fired as a test, and it hit it. But the 99% of shells that missed the missile flew on, and they shredded the bridge of another naval vessel, unfortunately killing at least one of the naval officers on the bridge at the time. Now, clearly that was never intended. But apparently what had happened was that in the design of the system, there wasn't a lot of thought given to rounds that missed, only to how do we get it to hit? So when the rounds were missing, they flew on. And the system wasn't really looking out beyond the target to see what might be hit when the bullets missed, as most of them did. Now, I'd like to tell you about another system used by a financial services company. And this system was designed to make decisions about loans. It would be able to read a loan application and determine whether or not that loan was a good risk, defining a good risk as it was going to be repaid. They gave the system 250,000 records of prior loans, including both the loan application and the results. That is, was the loan paid when it was supposed to be paid? And the software had to take those 250,000 records and analyze them to determine which factors were most related to the likelihood of successful repayment. Sounds like a perfectly reasonable thing to do. Well, the system worked on it, and one of the things that it figured out by itself was that one of the most important factors for whether or not a loan would be repaid was the postal code indicating where the loan applicant lived. And as a result, the AI then placed greater weight in loan approval or denial based upon nothing more than the address in the loan application. And as I said, that sounds like, it's a reasonable thing to do. You said you want to have the loans repaid. The system said, well, people in this area don't repay their loans. You weight it heavier, you give fewer loans. Unfortunately, that's not a very good thing to do. In the United States, there's a law called the Community Reinvestment Act of 1977. So it's been around a long time. And that makes it illegal to base lending decisions on the neighborhood where a person lives. Without it, what had been happening was that financial institutions would put up a map on the wall and they would outline in red pen those areas of minority communities, and they denied them access to loan services. That turned out to be what was called redlining. And this system, because it was not told about that, immediately learned how to do e-redlining. And that was disastrous. Why does this happen? Well, I think if you step back, you'll see that organizations often bring in AI experts to build their systems. And they either bring them in as employees or they bring them in as contractors. But those experts are experts on the world of artificial intelligence and deep learning. They're not necessarily going to be subject matter experts. They're not necessarily going to know what the laws are and the rules and the regulations relating to loans. They're focused on building a system that does what they're told it needs to do. Historically, they do not focus or even necessarily think about the legal or regulatory issues or the contractual agreements that a financial services institution may be subject to. If you have a system that is not going to follow the law, not going to follow a regulation, I would argue that however good that system seems to be in a conceptual sense, it's going to be a failure in operations. So the question is, when you're developing an AI system, or as an AI developer, can you really afford to hope that your development team figures this out or somehow research it themselves? And I think the answer has got to come down on the side of not a good idea. Now, that's a danger, but here's another danger. We've seen over and over again that bias can creep into the system during its development, particularly for deep learning systems, and that the standard practices in computer science that we use in developing a system aren't really designed to even notice that this is happening. Let me give you an example. A facial recognition system that was built for the use of the police was 99% accurate. But it turned out that it was only 99% accurate when the image that it was searching for was that of a white male. It was substantially less accurate in identifying women or people of color. This turned out to be because the enormous training set used for the system consisted mostly of photographs of white males. In the last few days, we've actually seen something very interesting happen. We've seen that Amazon has made a decision that its facial recognition software will not be used by police departments for the next year because they want to have a better handle on how to make sure that the system is accurate and that it's not doing too many false positives or false negatives in its operation. Now, another example involved Amazon, which had developed a new AI system to review the resumes of people that wanted to work for the company. Now, looking, obviously, to select the top-level talent. And there were a lot of people that wanted to work for Amazon. So they spent a lot of money and a lot of time building a system. And they trained it, given the resumes that had been submitted to them over the past 10 years. And most of those, we understand, were from men. So the AI system in its training mode, as it was running through these, penalized resumes that included the word women's. It also downgraded graduates of 2 all-women's colleges simply because of where they went to school. That was unacceptable. The system was apparently never used in live operation, and ultimately it was abandoned after spending all that money, all that time, and all that effort. So what can we do? How can we course correct our AI systems? Well, first, let's get some additional experts involved in defining and building AI systems, to include experts on the law. What is it that a system is lawfully able to do and not do? Let's look at compliance and regulatory specialists, like compliance officers. They're usually focused on things like, what are the regulations that the system has to follow? And what are the corporate rules that govern any system that's built? Things that the company wants and doesn't want. Well, let's get them involved. And then let's look at how we build data sets for AI training and later for testing. Can we make sure that they're large, but even more than large, can we make sure that they're diverse? The rule that I think you need to follow is that your training and testing data sets have to be as diverse as the ultimate population that you're going to be looking at. Looking at a subset doesn't help. And in fact, we've seen a number of cases in which a very large database was literally split in half, with half being used for testing, half being used for training. Well, given that the 2 parts were from the original same database, they had the same bias. So the testing didn't notice the bias. So what we want to do is get the legal, the compliance, and the regulatory experts involved in defining and building a system. If we look at this circle, it represents the technical capabilities of a system. That is, what a system could do if it was allowed to do it. Well, if we get the compliance and regulatory people involved, they're going to be able to define things that a system could do, like limit access by geographic areas, redlining, and say, no, those are not authorized actions. Their job, in part, is to define what it is that limits the action of the AI system, and to a large extent also say, if something bad happened, what evidence would I want to show that the system had worked correctly? So think of it as legal and compliance building a fence within the capability of the AI system that limits the freedom of action of the AI system. You can think of it as having areas that are safe, areas that are unsafe, and some areas that are questionable in which the system may seek guidance from its human overseers. So we want to collect the right data. We want to make sure that we're framing the problem correctly, not making it too general, too generic, too large. We want to be able to answer the important questions of, is the system operating within the set of laws and regulations and contractual and corporate provisions, or is it off in the wild? Will our training set support this? And will our testing data set let us know if this isn't in fact happening? Dealing with implicit bias can be very, very difficult because it's something that we may have grown up with. It's something that we may not even realize that we have. And you need to be able to step back and ask the question, is there a problem? Is there something that I should be noticing when the system is being tested, when the system is in operation? For example, an algorithm that's designed for one purpose might have been repurposed to speed up development of a system. And that's something that can often be a problem. Ultimately, even though the people developing the system are really technicians with a tremendous depth of knowledge in the technology, they need to be able to also stop and think about things like fairness. Is what the system doing moral? Is it optimal? Is it biased? And how can we avoid that? How can we look for it? How can we notice it? So we've talked about a number of issues, but I think it's important that we give you some takeaways that we think will be helpful to you when you're involved in the development of an AI system. Paul?
Thank you, Alan. Yes. To wrap up this presentation, a few key takeaways. So firstly, AI systems are being built in public and private sector systems. You know, we must accept that AI is growing, and it's not a subject that any of us can really afford to ignore now or in the future. And indeed, we should be looking, as Alan said earlier in the presentation, to embrace this kind of technology and the myriad of benefits that it can bring to us in our business and daily lives. Now, secondly, AI being built by computer data science specialists generally have the potential for no knowledge of the legal and social science areas. The need to understand legal compliance and evidence considerations really has parallels with how we operate in the cybersecurity world in general. You know, in our line of business, we do encourage the involvement of business, of legal, compliance, of risk managers at the very early stages of development of cybersecurity systems in order to ensure that they are both adding security to an organization, but also enhancing the business. This is really important. And in the same way, AI should have the involvement right from the get-go of the different lines of business and make sure it fits in with the business model and make sure it also matches the risk tolerance of an organization. Thirdly, we need to identify problems during design and build. It's far better to anticipate potential risk, ethical and legal issues during the design and build phase in order to avoid predictable problems. And lastly, as Alan has explained, AI can include bias. We need to be careful with training and testing data, but we have to emphasize that done well, the benefits of AI are compelling. However, done wrongly, they can introduce legal and regulatory challenges that may end up costing the organization far more than it costs them to implement the AI in the first place. I think, it's fair to say that we'd really all like to imagine a world where we're able to predict and eliminate human error or maliciousness in preventing insider threat and potential data loss. This is obviously something that's close to my heart and to Alan's heart as we are in our day-to-day work. We look to address cyber risk. We look to help organizations to mature and to protect their employees, to protect their clients, customers, and protect their critical information. It is probably one of the most common things that we as a firm investigate, data breaches, and anything that can be used, any technologies which will help us along the path of enhancing security is a good thing. An outcome that really in our world of addressing cybersecurity risk is certainly something that we all want to strive towards. I'd like to thank you all for joining us today, and we look forward to answering any questions that you may have following this presentation. Thank you very much.